So another class of compounds that are interesting to look at that are formed solids and that we interact with in our everyday lives are what we call polymers. And polymers, if we look at that word, poly means many. And so there are very small units that we refer to as monomers. So they're an individual chemical unit that once it reacts, it starts forming very, very long chains where we have lots and lots of these individual monomers that link together into our polymer. So for example, if we start with ethylene or ethene, when it links together into a long polymer chain, it's what we now call polyethylene. Okay, this is a plastic that gets used in lots of things throughout the course of our lives. And this long chain, when we talk about long chains, so when we talk about big molecules, you may have an idea of a few 100 grams per mole. But when we link these together, we are talking about 10,000 ethylene molecules being all linked together. So typically n to the fifth, or 10,000, or sorry, 100,000 of these units being linked all together. Now, each chain is not the same length. They vary, and so there's an average, similar to what our graph shows us here. So the average would be around that peak of that graph, and different chain lengths are some are shorter and some are longer. But we do end up with an average that is a very large number of these monomers. It results in a mixture. And they do, again, have very large molar masses. So see if you can look. So here's a couple of examples of a polymer chain. So you're looking for where would the monomer, what would the monomer be in this case? So see if you can take a minute, circle that monomer. So remember, this is a unit that repeats over and over, and so we're looking for something that's unique. So in our first example on the top, our monomer is going to include that ring side chain, and it has 2 carbons in the backbone. Okay, so we have over and over the same monomer unit that's linking together. So this example, this is polystyrene. So if you to-go containers or things that are non-reusable foams can be made out of polystyrene. Okay, how about our second example? What is the monomer in our second example? Well, this one's a little bit larger. We have a few more atoms that make up our monomer, but it does repeat over and over. So it starts with our nitrogen, and we go down to our carbonyl. And so this is the repeating unit. Okay? And this example is actually known as Kevlar. So Kevlar gets used for things that need to be very, very strong, that can withstand a lot of forces. So one example is using them in Kevlar vests. Now the reason that Kevlar is so strong is because we have, if we look at our structure, we have an N and an H. Okay, so if there's an N and an H, what type of intermolecular forces can form? Hydrogen bonding, absolutely. So in our hydrogen bonds, okay, we can have interactions between the chains of molecules that form these very strong links, and it's hard for things to penetrate. So like for a bulletproof vest, that bullet is going to lose lots of energy trying to get through these strong interactions between the molecules. So if we want to control the properties of polymers, we do have to look at a few different things. So it has a lot to do with how long the chains are. So the more of the monomers that we link together, the more of the dispersion forces or intermolecular forces that can form, and so the stronger that polymer is. Also, if we have those polar side groups like we saw in our Kevlar, those polar side groups can make strong interactions between the layers of polymers. And if we want to go even a little bit farther, between not just having those intermolecular forces, we actually can make physical bonds between layers that are cross links. So we can bond between those layers. So if we have a polymer and a polymer, we can make a physical bond between them, and that makes it even stronger. Okay, and so these are things, cross-linking. So if you've ever heard of vulcanized rubber, which is used in tires, that vulcanization process is actually taking sulfur to help link the polymer, those long chains of rubber together, and that sulfur actually makes the entire tire one molecule because there are bonds between the different chains. It's kind of interesting to think about that you could have something with the entire tire being a molecule. Another way is we can have branches. Branches can pack together very closely, they can tangle up, and again, that makes for stronger polymers. Now we do have a little problem because when we have very strong polymers, it can have negative effects like building up in the environment. Because they're very strong, they don't break down quickly, and it can lead to problems in the environment. So there are lots of different household plastics that we use. Okay, some can be recycled. Some are more difficult to be recycled depending on the type of plastic that they are. I'm sure that you've heard of some of these types like polyethylene, polypropylene, polyvinyl chloride, so that is PVC. So if you've ever, like plumbing pipes can be made out of PVC. Polystyrene that we talked about, those are like to-go containers, older to-go containers made out of foam. Nylon is an interesting one. So nylon is a polymer that can be made, and it can be made in very long chains. And polyurethane, as polyurethane is being produced, it actually gives off a gas, and so that's what makes polyurethane actually turn into a foam as well. Or it can be made into a polyurethane foam. So not only can polymers be synthetic, made in the lab out of petroleum products or from crude oil, but we also can have naturally occurring polymers or biopolymers made in nature. And so there's lots of examples of these like lignin and cellulose. So cellulose is what makes up the cell walls of plants. This comes from a glucose monomer that gets repeated over and over because we have these long chains and the hydrogen bonding between them. They're very, very strong. We can have some P3HB granules, which are organelles inside of bacteria, so they help make up that organelle. We have hyaluronic acid, which is an example, and this is found in the fluid in the eyes and also in your joints that helps to cushion as you're walking. DNA, now we have 4 different monomers in the case of DNA that make up its structure, but it is a polymer repeating pattern of these monomers that nature uses in order to encode lots of different information. And then also we can use them to introduce drugs into our bodies and into different places in our bodies, and we can tweak its solubility by the polymer that gets used. So one example is PEG, or polyethylene glycol, and so they use polyethylene glycol. It's actually the main ingredient in Miralax as well, but it is a polymer that, depending on the length of the chain, it can help with the solubility of pharmaceuticals that are insoluble. So there are lots of uses and lots of ways that we can tweak the properties of polymers. So I hope you learned a little bit about some of the materials that we use in our everyday lives.